Hello interwebs, welcome to Let's Fix Computers. There's an Acer E5 laptop under all these rad Boku no Hero Academia, or My Hero Academia, I'm not sure which one's more popular, you get the idea. Under all these rad stickers. I should watch this show, everyone says it's really good. Anyway, the laptop unfortunately does not turn on, it's stone dead. If I plug in a charger, we have no light on the front of the laptop. We should have a charge light there. And if I push the power button, nothing happens. Zilch, no signs of life, nothing. So let's open this thing up and see if there's anyone at home on the inside. Because it's stone dead, I'm expecting one of two things. Either there's a short circuit in the laptop, or the power management chip is dead. Or something like that, you know, some kind of system management chip. Either way, no idea if this is going anywhere or not. Let's find out. So I'm going to take all the screws out of this, take the top case off, and we'll go from there. Whoa, that's a lot of dust in that fan. Let me just give you a close-up of that. This is why you do your visual inspections. You can see that fan is blocked up completely. This thing has probably been having a bad day, I think. So, not a good start at all. Not a good start. All right, let's see what we can do with that. Oh, bloody hell, how'd you get into this thing? I think we're going top off. Always hard to tell with new laptops whether the top case or the bottom case is going to come off. There's very little way of knowing without just pulling it apart and seeing what moves. Now, speaking of which, I think it's actually the bottom case. Let's turn it over again. And we've got, whoa, easy, who's that? Speakers. Oh, that's a big oof on that fan. It might be okay. It might not be as bad as it looks because we've got a, what was this, Pentium, I think this thing was. It's a Pentium processor. It doesn't have a fin stack on it. This is literally just a metal plate. There's no fin stack or heat pipe here. So it obviously doesn't kick out much heat, but they did bother to put a fan on it. But that thing's just chocked full of fluff and dust. That's been, yeah, this has been on a bed or on a desk or on a dusty desk or something like that, you know. Common issue. Fine. Okay, let's disconnect the battery. Which I'm going to check for locking connectors. No, that's just going to come out. Okay. Cheap 4-cell battery. 2350 milliamp hours. God, that's depressing. Build in the batteries, they said. You can get more capacity in, they said. My ass. Okay, let's plug in a charger and see if there's power getting to the board. So, all right, charger is plugged in. So I'm going to check the back of this connector first. Ooh. That's some nice oscillations we're getting there. See that bouncing around? That looks like a short circuit to me. Let's unplug that a sec. Should go dead now. Yeah, okay, let's just check the resistance across there. So I expect... Oh, that's a big oof. That's a dead short across DCN. Oof. Well, that shouldn't be too difficult to track down. So the DC in jack, I expect to see anywhere. Typically, I'm looking for 50 plus kilo ohms. So 50 to 200 kilo ohms. Sometimes it can go down as low as like sort of 20 or 30, but in the most cases you're going to be in the kilo ohms range. Right now we're on ohms, not even kilo ohms, and we're at about 1 ohm. So that's basically a dead short to all intent and purpose. So yeah, we've got a dead short. That's why there's no power. I'm impressed that the power supply stayed on. The power supply is getting dragged down to 0, and then it is bouncing up and down as it tries to cope with the dead short load. So yeah, that's what's going on with that little oscillation we had there. Fine, okay, right. Time to get the board out then, because we've got to start probing around these areas. Because we've got a dead short directly on the DC jack, I'm expecting to find that short circuit fairly close by, because on a typical laptop, your power comes in through the charger jack into the board at DC in, and then almost immediately it will go through an inrush limiter, which will be one or more MOSFETs that just basically switch in the main power input, and they allow the laptop to switch off the incoming power and things like that. It also just makes sure that you can't get, sudden surges, and it's just first level filtering. Not very sophisticated, but just, sanity check filtering. So because we've got a dead short at the DC jack, I'm expecting to find the short at or before the inrush limiter. If we had a low ohmage, like if we were seeing like, I don't know, 20 ohms or 50 ohms or, like 100 ohms, but not kilo ohms, then that would imply that there could be a short circuit deeper inside the laptop on the other side of that inrush limiter. But this looks like a really obvious short circuit somewhere fundamental. Hopefully it's not something really obvious, but we'll find out. Anyway, time to get the motherboard out, and we'll go short hunting. And with a bit of luck, something as blazingly obvious as this short will be easy to find. Okay, so let's follow along. So positive pins were on the right. We have positive, positive, negative, negative. So the power comes in at this point, and you can see a big fat power trace there. Very obvious right there. So that is going into, we've got some immediate capacitors there, and that's going into this fella here. So this is this might even be the inrush limiter right there. And then if we have a look over here, this is probably the battery charger, because our battery connects there, and we've got a buck regulator here and a controller circuit. So this is probably the battery charger, and that is going to join up to the DC input there. So again, battery charger is a prime suspect when you have short circuits like this, and a short circuit in the battery charger will probably appear as a fairly low short on the DC in jack as well, because the battery charger is very close to the DC in jack. So that's this is another prime suspect area here. So we've got that guy there, and then it kind of disappears here. We've got sort of outputs around here, a load of vias and stuff there. Let's flip the board over and see what's directly on the other side. So directly on the other side, we've got these two guys here. So this is all clearly big power here. Again, big traces, lots of via stitching, big components. And we've got a big fat trace going off down through the board there. Where does that go? That's going just up in the direction of everything. So that is, and then we've also got more big fat traces over here as well. So we need to start probing around some of the secondary power supplies of this board to see where the short appears, to see if it's across the entire board or if it's isolated around the DC input area. So let's start going for a little bit of a wander and just see what buzzes. Okay, so black probe on ground. So let's start from the top. Yeah, so the positive DC jack is directly shorted to ground, which we already know. So now I'm going to go over and I'm going to buzz these secondary power supplies over here. So each of these little blocks here, those are inductors or coils, and generally speaking, these big inductors, they are secondary power supplies. So they're taking the main power rail in the laptop and then stepping that down to lower voltages, such as 1.1 volts for the RAM, probably 1 volt for the CPU. There'll be a 5 volt rail and a 3.3 volt rail for logic, that kind of thing. So let's buzz those out. And those secondary power supplies look good. I was getting some beeps off the negative side of the capacitors, which is obviously completely normal. But the coils and the positive side of the capacitors were not beeping at me. So that's a really good sign. It looks like our VCC main, so the main power rail of the laptop, is not shorted to ground. That's a really fantastic start, because when VCC main is shorted, then you've got a big problem, because the short circuit could basically be anywhere if you've got that. And as you guys will have seen from my previous board diagnostic videos, short on VCC main is bad news. It's not game over, it just is bad news. Yeah. Okay, so let's have a closer look around DC in. So again, I've got my black probe on ground, and once again, if we come around to the input of this chip, we're shorted. What about the other pins? No, no, no. And the bottom left one is shorted, but this is probably ground, because this chip has got to have a ground pin on it somewhere. The top right is definitely not supposed to be ground, because we can see that trace goes to DC in. So that bottom left is clearly supposed to be ground. So from that we can determine this chip itself is probably not our issue. Let's try some of the capacitors around this area. This guy is almost certainly going to be shorted because it's on the shorted line. Ah. It's not. That's unexpected. Okay, I don't know what that's doing then. We'll come back to that. That it doesn't make sense that that isn't shorted, because it's connected to a shorted rail. Huh. Okay, fine. We're gathering information. Battery charger seems okay. We're getting ground on one side of the caps, but not on the other. So that all seems fine. Let's check around. This is probably V-core. V-core might be over here, under here somewhere, but let's just check these guys. Those guys look fine. We've got a ground plane in the middle there, and the other sides are not grounded. Again, one side beeps, the other doesn't. That's exactly how we'd expect it to behave. All right. Let's have a look on the other side of the board from this thing. So I've turned it 90 degrees for the ease of use, so the DC in jack is now pointing out in that direction. Ground check. Okay. Right, this is all shorted out. The input to this guy is shorted, but the output is not. I'm not sure what that is. I think that's a MOSFET. It must be. Those guys all seem fine. So our problem seems to be around here. I wonder if it is just those guys. Well, you know what? There's only one way to find out. Let's just pop those straight off the board and see if it's that simple. I mean, if you look here, these pins here, 1, 2, 3, 4, those are the pins of the DC in jack. And we've got a bunch of filter capacitors directly across those. And this guy is a reverse voltage diode. So if the DC jack is plugged in the wrong way around, then it will short across this diode. So it's possible that this diode has failed short, and that is our problem. And it might actually be that simple, which would be amazing. I never get the simple ones. I never get the easy ones. All the other YouTube channels get the easy ones. I never get the easy ones. Where's my stuff? Oh, here it is. Oh. Time for hot air. So here comes the hot air. I'm at 420 degrees maximum airflow because I'm impatient and I have a cheap hot air gun. And I'm just going to heat up the general area, and we're just going to take off basically that entire section. I'm just going to, well, actually, you know what? I'm going to take off just the diode first. Because if the diode is the most likely culprit based on what we're seeing right now. So yeah, if we take off that diode and our short disappears, then we're done. Otherwise, I'll just keep taking off those capacitors. Because one of those capacitors might be our guy as well. Okay, we're going to wait for the board to cool down. We're not going to take readings while the board is sizzling hot, because when you heat the board up, the board will probably flex, and that may cause things to touch that are not supposed to touch, and things like that. I've seen short circuits appear and disappear through heat cycles, so you generally want to make sure that you let the board calm down a bit. Well, it doesn't have to go down to room temp, but just not be at 400 degrees, basically. Ground check. Okay, our short circuit I think has gone. Although what's confusing me is that this side is denoted positive, but I think that might be for the diode. I'm not sure which side is the positive of our input here. I think it's that side. Yeah, I'm correct. That side is grounded. This was previously shorted to ground and now it's not. So I think we're good. Let's check our diode. So here's the diode. Yeah, that's shorted in both directions. I think it was that simple. So something gave this thing a massive reverse, potentially a massive reverse voltage. Or maybe this thing just fatigued. But the laptop isn't even that old. Alright. Cool. I think we're done. I think if we plug this thing in, it's going to light up. So I'm just going to do that. And then the next question is, are we going to bother replacing that? I probably should. It's saved the laptop once already. I don't know. I can't remember how important reverse diode protection is. I wonder if she used the wrong charger on this thing. Or he. I think it's a daughter's laptop. I don't know. Anyway, I wonder if the owner of the laptop plugged in the wrong adapter. They plugged in an adapter from something else and it fitted into the laptop, but it had a positive outer pin or something like that. And it just reverse biased that diode, blew it up, and then the laptop wouldn't work with the normal charger. That would be a pretty good theory as to what happened to this thing right now. Okay, plug in charger into side. Please don't blow up. We have a charge light. And if I push the power button, we have a power light. And do we get display? Beautiful. And we should get no operating system because the hard drive isn't connected. Oh, we've got checking media in the top left. That's good enough for me. Wonderful. All right. Diagnosis complete. Okay, I had a hunt around on my other scrap motherboards and I found this guy, PJ55SS12. I Google searched that and this is a generic rectifier diode and it's rated for like 30 volts or something like that. So this should be perfectly fine as a suitable replacement. I'm not convinced that this board needs a replacement because I also had a look around because I was just like, I haven't really seen reverse diode protection on many motherboards on laptops. It's not something like, it's a known thing to stick a diode across your input for reverse voltage protection, but I've never really seen that on a laptop. I think they normally rely on the inrush limiter to handle that. So I'm not sure if we actually need it or not, but just for safety, I'm going to put it in because I can. So yeah, I found this generic one. It's not an exact match, but whatever. I'm sure it'll be close enough. I didn't design this motherboard. I'm sure the people who did design it knew what they were doing. So I'm going to put another diode there. And if the laptop comes in with another blown up reverse voltage diode, then we'll just take it off and leave it off the board. However, also, just for good reference as well, when the customer comes to get this laptop, I'm going to say, bring your charger with you. I want to see what charger you're using. And if they show up with a third-party charger, I'm going to tell them to bin it and get a proper original one. Or rather, I will sell them a proper original one. So, let's get this thing back on the board. I'm just going to hot air that on. That'll be all right. I'll put on a little bit of flux to help out, but I don't think we need to go to town and clean up all the surfaces and stuff. That's a little bit overkill. And the stripe goes toward the bottom. I'm going to turn down my airflow. If you're blowing the component away, turn down your airflow. That's what the airflow dial is there for. Damn it. I've turned down my airflow, now I just need to get good and not blow away the component. I've already blown away all the flux. Oh no, that's actually going to need soldering. I'm not going to get away with being lazy, I don't think. We'll touch that up with the iron, just for good measure. Did that even stick? It did. Yeah, we're all good. That is all behaving as expected. And we've got a nice little reverse diode protection diode there again now. Right, so to summarize, for the folks who are just like, I don't understand what just happened, on the input, so where the DC jack connects to the motherboard, there is a diode, that's that guy, that is directly across the positive and negative terminals. A diode only allows voltage to pass in one direction, up to a point, asterisks, blah, blah, blah. So this diode is there to only allow the current to flow in one direction, and it is positioned against the flow of normal voltage. So when you plug in the laptop normally, the diode does nothing. However, if you plug in the charger the wrong way round, which obviously you shouldn't be able to do because it's a barrel jack, but if for some reason you plug in an incorrect charger, or the wires cross, or for some reason or other voltage flows in the wrong direction into the laptop, then that diode will begin to conduct that voltage directly across to the other side again. So instead of the voltage going into the laptop in the wrong direction, it will come straight in, go through the diode, and go straight out again in a dead short. And that then means that the power supply will cut off, stop, break, blow up, instead of the laptop blowing up. So that's what that reverse voltage diode is there for. I'm not convinced it's necessary. I think the inrush limiter should be able to do that. However, the one we had failed, and it may have failed because it's a faulty component, or perhaps it failed because an incorrect charger was used. Who knows? I'll be asking the customer questions to see if I can determine what happened there. But either way, we've put a replacement one in, so just in case they do try and use a bad charger again or something like that, there'll be something else to protect it. Alright, let's get this thing reassembled. Oh yes. I could just blow all this out, but it's somehow more fun and satisfying this way. I'm going to get the airline. Lovely. Right, there we go everyone. This one's off to the service bench. Thank you very much for watching. I'll see you all next time. Bye for now.